So this is going to be about search, and it's supposed to be a rather general introduction. Where did I come from? I'm a physicist by education. I have worked a lot with hypothesis testing, both as a researcher and as a data scientist now. But I have also worked with the recommendations, and the company that gives me the opportunity to work with search from time to time is Automatic. We are responsible for a range of products that are all about publishing and having an online presence. Like PyData, we care about open source, so a lot of our developers contribute back to the open source WordPress software. And we are also a very special company in the sense that each and every single one of my 550 plus colleagues works from wherever they want and wherever they want to live. So we are 100% distributed. Even so, we do meet from time to time. So this is the data division on our recent meeting in Montreal last month. We are responsible for a range of things, even though we are not that many people. So we do tracking, we consult with other teams, we keep our Elasticsearch applications up and running, we do A/B testing, we do lots of stuff. We build applications on our data. And we care about search because, well, I forgot to say that. So the most notably, we have this platform called WordPress.com, where anyone can build a website or a blog. And because of that, we do have a lot of text data that we would like to make searchable and discoverable for our users. So this top graph shows that the number of posts that are published on our sites, and this little animation shows some activity on our platform that includes both posting, but also comments and other social interactions. And I took that on a Monday morning in Europe, so that's not the busiest time. So we have lots of text data, and our division is actually responsible for one user-facing application, which is the Reader, and that's a place where our users can follow sites, and they can also search for sites and get recommendations. So when you search for PyData, for example, you got some blog posts about PyData. The last one is from one of my colleagues who gave a talk a few weeks ago about an anomaly detection that he wrote. So last year we built this search into the Reader. But of course, when we do that, we have to, the first thing we should ask ourselves is like, what do users want when they search? And that will depend on the user. So a user could come to your search application with different ideas. So let's say if we're talking about a person who is maybe thinking about going to South Africa on their next vacation, they might come and search something like Lions, South Africa. And that's probably because they want some information. So that would be an informational search. But sometime later, they might come and search for flights Cape Town or a lightweight tent. And that's because they probably want to buy something, or they may want to make a transaction. They want to book that flight. So we call that transactional. And on the day before departure, they might search for, I don't know, Lufthansa web check-in, because they want to check in, but they just can't find that site. So they know exactly where they want to go. But they just don't know how to find it. So like a search engine like Google serves all of these cases, but if you build your own, maybe you don't need all of them. So you should take a look at your data, and if you have some search application running, and see what are your users actually looking for. And we did that with our data. It's a little bit old, this plot, which means you might still find like a Pokemon in there or something like that. But this is a word cloud of searches that our users performed in our Reader. And the bigger the font, the more unique users searched for this term, because we have some like power users who search a lot, so it's better to just look at unique users. We can see some things in here, so you might see that some of the words are not complete. That's because we run a search as you type application, so they will, if there are slow typos, they will already see some results popping up while they're typing. And you can see some of the types of searches that I mentioned on the previous slide. So for example, dashboard, which is like somewhere in the middle, is where our users can edit their site settings. So this is a navigational search. They wanted to go there and didn't know how to, which is not nice, but that's how it is. But you also see that most of these searches that we have are very broad. Like people look for very broad topics, and those searches are probably not even like informational searches, because I assume that our users already know a thing or two about things like fashion or travel or books, right? So these are probably searches where our users want to find some inspiration, or maybe they are looking for a community of people with similar interests to their own. So what we learned from this is that, for example, something like popularity of a post is probably something that our users care about more than the actual information contained in that post. But of course, like, popularity is nice, and a lot of search engines will take that into account some way. But of course, users want more than just popular posts, or just posts that mention, or documents that just mention a word that they're searching for. So on this slide, I'll summarize a few things that users might expect when they come to a search engine. So, of course, we all are used to Google and like very fancy search engines, so that when we search something, most of us will just accept magic, so that the thing magically knows what we're looking for. But there are also a few more actionable items that we can look at. So users want, of course, relevant content. When I search for Lions South Africa, I want those words to appear in the text. And most of the traditional literature about search engines will focus on that. But there are other things that are great, which is, for example, original content. It is always better to send a user to the original source than give them a lot of pages that just cite something. We also tend to prefer expert content. So it's better to give pages or documents that are written by someone who knows their stuff. But at the same time, it's also good to return results that have some level of clarity, so that are written at a level that the user can understand. And of course, you don't know a lot about the user, but for example, if I search for giraffe, you would maybe want to return something different than if I was searching for the Latin name of some species, because then I'm probably more of an expert in that field, so I would want to have more like biology type of scientific papers. What more? Yes, of course, new content is also something that users like. You never want to send people to sites that are not trustworthy. You don't want to have spam in your list of results and stuff like that. So that's important. And also diversity is important. If, for example, if I was searching for introduction to programming, you would not want to return 10 results that are all called Introduction to Programming in Python, even if Python is your favorite language. As long as you don't know much more about me, you would want to return some mixture of programming in Python, programming in Java, whatever. And finally, another thing that is important is high precision. So something that users tend to do, or all people tend to do, is when you give them a list of search results, they try to gauge if that list is actually good or not before they trust you, before they click on something. So they will not just, even if the first result is top-notch, if the following 3 are bullshit, users will not trust your search engine. So that's called high precision. So you want a lot of relevant results high up in your list of search results. So yeah, that's what we want. Might sound a little bit overwhelming. So, but then let's just look at what is a search engine. On the high level, it's a thing that connects a user to a document collection or maybe the whole internet. But under the hood, there are, of course, more things. Like if we speak about the internet, you need something that collects all the data from the internet. So that will be a crawler, and that will insert it into your document collection. In our case, that's much easier because we mostly search through the documents that are produced on our platform. So we already have that. So I will not mention the crawler any longer. Then you will want to make these documents searchable. And that's a task that is taken on by the indexer, and the searchable data is stored in something that's called index. On the far other end, you would want something that interprets what the user wants. So at the very least, you will have to translate the terms that the user types into something that you can feed into your program. But you might also want to do more. So that's called the query builder. It produces a query. And then finally, you have the ranker that puts everything together and gives you the best list of results to match your query with the index of documents that you have. And then you return that to the user. And we will look at several of these components in more detail. So the first one is indexing. So that's about making documents searchable in a very fast way. We could have a document like this, which is very short, but is a nice text, a brown doc met two black docs. So of course, that's easily searchable. But if you imagine you have a lot of documents and you have someone searching for doc, you don't want to parse every document every time that someone searches. So you need to put these into a different format. And a good format for that is the one on the right. So where you turn your like string text into a list of terms that appear in this text, and you store the counts with them so that you can easily access them. And we'll have a few slides that will talk about how you go from the left to the right. Of course, most documents have more structure than this sentence. So in reality, your index will have more fields. So a two document could have a title and a body, and you would want to analyze the title and the body. And of course, you might also want to have additional information that you want to store along with this data, like other features, like, for example, when was this post published, how many pages linked to this web page. Maybe if you're Facebook and you have likes, you probably want to store the likes along with the posts. So yeah, how do you get from the left to the right? The first step that you have to take is, of course, tokenization. So that's you have to divide the text into meaningful tokens. Most often, those are words. Could also be sentences or n-grams. And this task is, for some languages, it's relatively easy because they're white space separated, like English or German. For other languages, it's more difficult. So I do not speak Chinese, but this is apparently a famous Chinese poem, and I ran that through a tokenizer. And it told me that in some cases, two of the characters form a word together. So you cannot just assume that every character is a word. And if someone speaks Chinese, they can tell me if that's correct, what the tokenizer did, because I couldn't tell. Right. But even if in a language like English, where it's easy, it's important to think about the tokenizer, because even if it's very good, every mistake that you make at this level will be all over your search engine. And there are some things that you have to think about. So even in English or German, there are some challenges. Like, for example, you would want to decide how do you treat named entities that consist of several words. Do you want to index that as Empire State Building or as Empire and State and Building? If you are looking at sentences in some way, you'd have to decide what to do with abbreviations that come with a dot at the end. Or even like abbreviations like US, you'd have to decide is that one term or is that two terms, U and S. Names, dates, and times, numbers, dates, and times come in many different formats. So you might want to bring them all to the same format or not. You might have to think about what you do with all the punctuation in these numbers. Then, of course, then in English you have nice things like sheet, she can't. So do you want to store that as can't or is it cannot? And then words in a text can be hyphenated for many reasons. So either it's because the author wanted that, or it's just because the word is at the end of a line. So you also have to handle that in some way. And there is a very nice blog post on the IBM developer blog about that. And I guess you can't read that, but I guess later you can download the slides and click on the link if you like. So this is, I didn't expect this room to be that big, so the font is a little bit small. So, but this is just an example where I took a text from the Wikipedia page about giraffes, Giraffes are sort of the mascot of our team, or our vision. We like them. So we have a lot of examples with giraffes. I took this text from the Wikipedia page. It's not the best Wikipedia page I've seen, but and I ran that through two different tokenizers that are available in Python. And in orange and highlighted, you see the differences. So they treat this is text blob and spacey. They treat punctuation differently and hyphenated words. So if, for example, if you would run a tokenizer like the one from Spacey in your search engine, you would have a hard time if your user later on wants to find even-toed animals, because you'd end up separating this word. Other analysis that you could do on your text before you store it in the index is stemming. That's bringing all the verbs back to their root form. Lemmatization, which is like turning plurals into singular and so on, and maybe removing the most common words. So if you had a sentence like the girl's car are different colors and sizes, if you apply a very strong stemming and lemmatization and stop word cleaning to that, you just end up with girl car be different color size. That could be useful. If you apply the same to the University of the Universe, which is, of course, like a place that we would all love to attend, you just have universe, which is less useful. So in general, if you look at these methods, you'd have to make a trade-off between recall and precision. Recall is the number of the results that you can return for a search query. So if you apply this, and someone searches for car, you can return many more results than if you do not. But at the same time, you lose precision. So if I want to know about girls' cars and I want them to be plural, I have no chance to find that if I remove that information at index time. How do we implement that? Do we have to write a lot of code for that? No, luckily not. So there are products out there that do a lot of this indexing and analysis for you. We use Elasticsearch, which is a search engine built on Lucene. It has a lot of nice features, such as it comes with a lot of analyzers that you can just use out of the box. And it also has a nice query DSL to work with. We run several Elasticsearch clusters with hundreds of terabytes of data, and our data engineers are really great with that. Some of these, they support something like 60 million queries per day, I think, and 12 million index operations per day. We have a lot of use cases, not just post-search, but also we run recommendations on Elasticsearch related posts, a lot of internal use cases, also some stuff for our VIP users. So we also have hosting for like big professional websites, like news websites, and they also have their own Elasticsearch applications. And this graph shows that over time, like from beginning of 2014 until today, we're running ever more Elasticsearch queries. So a lot of Elasticsearch queries at Automatic. So let's, okay. So how do we build these queries? The query builder has the task to take the user's input and turn it into something that the machine can understand and interpret. So at the very least, the #1 rule for query building is that if you run your queries on analyzed fields, you have to apply the same analysis to your query that you applied to these analyzed fields. So if you stemmed all the words in your index, you have to stem all the words in the query as well. So we'll look at an example for this. So this is similar to what we do. So let's assume we have a user who is searching for dancing unicorns on rainbows, which is probably something that gives them a lot of very colorful, very nice pictures. But they were kind of slow, so we only have this token there. So the first thing we do is to tokenize that. So we divide it into its individual words. But we also keep the full string so that we can also search for an exact match. We do remove very frequent words, so the on would probably go away. We apply a rather light stemming, not the hard one that I showed on the page on the slides before. So we'd have to apply that to all the words. So in our case, that would turn the unicorns to just unicorn. And then we have to apply for search as you type, which means that we do not want to look only for rain, but we want to look for everything that starts like that. Luckily, we don't have to do all of this ourselves. The first 3 steps come automatically in Elasticsearch, so we don't have to worry about that, and that's nice. And as I mentioned, we only apply a rather light stemming. So if you go like to our search and you search for traveling, and for travel, you will get different results. And Google also behaves in a similar way, but they have they have way more data and way more resources. So in their case, the distinction is way bigger than in our case. So let's look at what an Elasticsearch query looks like. So this is an example of an index with just of inserting just 4 documents into an index. It's from the Elasticsearch documentation. So they use this nice example about the fox and stuff that everyone uses. So we have the first element is the quick brown fox. The second is the quick brown fox jumps over the lazy dog. And the quick brown fox jumps over the quick dog. And brown fox, brown dog. Nice poetry. So an Elasticsearch query to match a word with these fields would look just as simple as that. So in the index has the titles of all these documents, and you just say like, we want to have the word quick in that document. And with like a sort of popular ranking would tell you that the first document is the most relevant for this query because it does contain the word quick and it's also short. So the fourth one would not be relevant at all, and the others are sort of in between. So that's of course just like a very simple query, but Elasticsearch has way more stuff to offer than this. So you can like combine different ways to search across different fields. You can apply a different weighting to different fields. You can use function scores to achieve whatever you want. And you can also use aggregations to kind of summarize your data. So I'll show you a query that one of my colleagues used, which combined, where she wanted to find like higher level information in our data. So she combined several bulk queries. So and there's the option to say like my documents have to fulfill a certain condition. That's the must in the bulk query. So she said I want to have posts from the beginning of the year, and then she combined several queries in a must and in a should. So that says it's better if it matches, but it's okay if it doesn't. The minimum number should match equals 1 says that not every condition has to be fulfilled, but at least one has to. So she looked for posts that have either in their title or in their tags or in their body the words new and resolution, because she wanted to study posts about New Year's resolutions. And then she applied an aggregation by the date. And she got data from which she could directly make this plot, which compares like when do people post about New Year's resolutions to when do they post about dogs. And people post about dogs all the time, but they only post about New Year's resolution at the beginning of the year. A query builder can write queries like that, but they can also construct way more complicated stuff. So here's sort of an overview of what else a query builder could do for you. So you could make it guess which language to search in, which would be pretty nice, because people don't often have their browser language set to the language they search in. So we happen to find out. It could find and correct spelling mistakes. That's painful for users if they have a spelling mistake and they see no search results. They could mine similar searches so that they can suggest better search term. You all know that from Google. They could expand the queries to find more and better results. So that's, for example, about the question, if I go and I search for eat Myanmar, maybe if I have posts about food and Burma, those would also be relevant, but the user didn't tell me that. So I could expand the query to also take related terms into account. And it could pull in features for personalization. So it can be arbitrarily complicated, if you like. Then the final component of the search engine that we want to talk about is the ranking. So you have the query, you have the index, you have to put them together and find out which documents are the best. The most naive approach is, of course, to just look for the words that are in the query and count them in your posts. So you could go just by frequency, which is not that great. So the first thing people came up with is, instead of going with frequency, you could go with the frequency or a function of the frequency of the term in the document, but you normalize it to the term's frequency in your whole collection. So that means if I search for, let's say, the giraffe, and I would just approach that very naively, I could end up giving the same word to the and to the giraffe and to giraffe, while documents that contain giraffe will be way more relevant to my user with that search query. So that's TF-IDF, like the most basic ranking function ever, just the word frequency divided by the its frequency in the document collection. But it's not so great, because with a function like that, you still have a lot of your relevance still increases a lot when a user uses the same term over and over again. So this could work if you were working with like scientific papers where people have strong guidelines about the way how you write this text. But if you have users who like do some SEO and stuff, TF-IDF TD-IFF is not great. So people have come up with different ranking functions. One of them is BM25, which is a family of ranking function that is actually just a modification of TF-IDF that has two parameters, K and B. And it sort of regularizes TF-IDF so that it doesn't grow that much when you repeat a word a lot of times. So it still has the property that the more often you have a word in a document, the higher the score. And still, if the term is not very frequent in the whole collection, it also gets a higher score. But there is a penalty for like having very long documents. So if you just repeat the same word over and over again, it doesn't get you that far. And compared to TF-IDF, it doesn't scale as much with the number of times that a user repeats a word. So in this plot, I compare a version of TF-IDF to its modification in BM25. And it's for a document of 500 words. And it's shown as the number of times that I repeat some term in the document. So if n is 0, the term does not appear in the document. If it's 500, it's a document that's just 500 times the same word. And the y-axis is the score at this number of times that the term appears in the document, normalized to the score to when it appears only one time. And you see that TF-IDF still goes rather quickly, while BM25 is more behaved and sort of levels out, so you don't gain if you keep repeating the same word. So that's like two of the most well-known functions just for relevancy weighting. But of course, then there are other features, especially when you look at the internet. So, of course, what does the internet have? It has the links. So then there is the famous PageRank algorithm, which does not rank documents necessarily by their relevance, but first of all by their importance. So it does a link analysis, and the idea behind that is that the more important documents have more incoming links than the less important ones. And if a very important document links to my document, then my document is also more important. So if you imagine that all these squares are documents, D to 1 to 9, and this is a sort of a graph of a small section of the internet, you see that, like, for example, a random walk over all these links would lead you to D3 many times, but never to D9. So the page rank of a page is calculated as some constant with the parameter D, plus a weighted sum of all its incoming links. And that sum depends on the page rank of the pages that link to my document, divided by the number of outgoing links that they have. So even if like a page rank is great, if it just links everywhere, it also doesn't count that much. So you see this is because the page rank appears on both sides of the equation, so it's a recursive algorithm. So this is nice and cool. It's the famous paper and stuff. The downside of this is, of course, that people know about this, and they, they try to get around it. So this is, of course, very, very vulnerable to link farming. But you can do stuff with this, and you can also make modifications of it. So, for example, two types of pages that users like to see a lot in search results are called hubs and authorities. So a hub would be a page that collects good sites or good links to about a certain topic. So maybe I know about something, and then I just collect all the good articles about that on my page. So that's a helpful page for a user. And an authority is a page that is written by an author who really knows about the stuff. So if you start with the hypothesis that good hubs link to good authorities and vice versa, you can use a similar algorithm as for PageRank to identify these pages. Of course, you'll have far less data, so this is more vulnerable to problems that you can run into because of too little data. Now that we have I've looked at ranking and at architecture and stuff like that, let's look at one thing that data scientists might tend to overlook, which is the presentation. So when you have a search engine and it's user-facing, it's super important to have good designers and front-end developers who make it really nice, because it's, from our experience, like sometimes we tweak the algorithm and it doesn't change as much as a simple design change could make. So, that's because users want to trust your search, and they are sort of looking for information to validate this search works. So things like thinking about the length of the abstract is important. It's important to think about like which extra information do you want to show them. So for example, we show likes and comments, which are sort of like a social validation that this is a good content. Or we show extra tags, which also seems to work very nicely, which gives them more context. So this can have a big impact, and having a good designer on your team for a search engine is really great. So I'll skip this. I have a list in tiny font with the recommended sources and reading, so you might find this. And then lastly, a small plug for our blog. It's called data.blog, and we write a lot of stuff there. So thank you for listening.
We have time for a quick round of questions or a couple of quick questions. Hello. At the beginning of your presentation, you had a slide with a word count, with a word cloud. Could you switch back to that? Some of those very first slides. Yes. In terms of PageRank, what do you think of this upper right corner word HTTPS? Is this a tweak and the PageRank went wild? I mean, nobody's interested in HTTPS.
No,
no
one's interested in that. That's because not all of our users understand the search engine that we provide to them. So that's most likely, I think, a user. It could be two things. It could be a user who is trying to navigate to a specific page, And because we have search as your type, then maybe, when they're done with the HTTPS and they try to look for the colon and the slashes, then they're a little bit slow, so we give them results for that. And the other thing is, I think I made this plot very shortly after we introduced HTTPS for all our sites. So maybe they were actually interested in that at that time. We don't, probably a combination of both.
Hi, thanks for the talk. A question about stemming versus lemmatization. Question one is, do you know any, I think all of what you were telling about was about Elasticsearch. Are there any built-in tools for lemmatization? And from your experience, does it give any advantage in terms of relevance or precision if you do lemmatization versus stemming?
If I didn't catch one of it.
If you apply, so when you're processing like when you're creating the index and you, instead of stemming, use lemmatization, does it improve your results, or is it sufficient to just stem the words?
So in our case, what we found is that it hurts us if we apply these methods too rigidly. And I think one of my colleagues has written like a whole very long post about this, so he could probably tell you more. But and even more than in English, I think it's hurtful in some other languages. So we usually apply a little bit of both, but very, very lightly.
Hello. How do you measure the quality of your search?
So in general, there are different ways. For us, we know that there is a big variety of the quality or like say the engagement of our search results depending on the search term. Because well, for some search terms we have a lot of data and for some just not. And some are also like much more difficult to treat than others. So in general, we have to limit ourselves. So for something that we can run on all search terms, we have to limit ourselves to rather simple metrics. So we mostly look at the rate of some sort of interaction with the first 10 search results. And depending on what we want, this could either be if the user clicks on that, but we also want to engage our users. So it would be great if the content we showed was not just like, did not just have like a clickbait title that they click on, but we also want them to like or comment or follow the site. So we will often like look at something like interactions with the first number of results. But that's mostly because we cannot do much more than that for most search terms. We could do more for like travel or fashion, then we could really mine the search logs, but we don't yet.
So we don't have more time for questions now, so you can probably ask her directly. So thank you, Sirin, for your talk.